IGEMS has added a couple new commands in release 4220. We'll take a look at, first of all, we'll take a look at this new command, geometry optimization. And if perchance you are using one of my customized toolbars, you won't find the geometry optimization command on there because you would need to update your toolbar for this new command, which I've got my new toolbar here I've updated. So if you want to go to the default IGEMS toolbar, you can go into your preferences, general tab, and toolbar. You can switch that to default. And now we're on the default toolbar. So on the default toolbar, cam tab, part submenu, we've got the new geometry optimization command. If you are using my customized toolbar and you want to update it for this, you can of course go to the all-important ikulu.orjet.com IGEMS page and then go down to the customized 2D toolbar and click on that, and then as it says here, copy it into your app folder. So then once you do that and you go back into your preferences, general tab, switch to that updated toolbar, you should then have the geometry optimization on the part submenu and also the slit command, which, as they've noted in the release notes, they've now got a separate icon for the slit command. We'll look at that one in a different video. So that's great. We've got that. What is geometry optimization? I guess that's the first thing to understand. Basically, when we go to create a part, we've got this box here, geometry optimization. And it's going to use whatever number here. It's going to look at little channels like this that you might have in your part and try to determine whether these are wide enough for the stream to get down. And anything that's 45 thousandths of an inch and smaller gap, it's not going to let you go down there if you have the geometry optimization box checked, with the idea that you probably don't want to make these slots wider than they're supposed to be. If I click OK at this point, it looks at these, and because this one is 045, basically stops there, and you can see what it does on those smaller ones. So let's take this back a step. And where does that default geometry optimization come from? That's another good question. That's under your machine settings. Go to your select icon and click on your edit machine, and then geometry. So that's where that geometry optimization value comes from. If I change this to 042, then when we go to create the part, we'll see that that will be the new value. And the idea with this is you put in a number basically as large as you're going to let your stream grow to. So we'll leave it as 042 for right now. And there's our new geometry optimization number, and we click OK, and now it gets down that slot, but these ones are still too small. Now if we have enough tolerance and we don't mind if these actually end up being wider than what they're called out at, then that's where this geometry optimization can come in handy. Rather than having to explode the part, change that geometry optimization number, do it all over again, you can now just go to geometry optimization here. And this is per toolpath. Since this part has one toolpath, it's going to affect the entire part. I'll show you another one here that has multiple toolpaths. And then if we say, all right, yes, I want to be able to get down this 035 slot, basically have to set it just slightly smaller than the smallest area that you want to be able to get down. So if I set it to 0.0349, then it can get down there. When we go to add the toolpath, we've got this. So this red line here would be the toolpath as we're coming down into the slot in the hole. And if we were to draw in a circle here, I'm going to turn off my snaps, just going to have to eyeball this as close as we can. And I draw in 0.042 diameter. Then we see that we are going to cut into the part a little bit on this side, and similar fashion on the way out we'll cut into it, so it's going to come out a bit wider than the 035 called out. But again, if you've got the tolerance, then hey, go for it. Now where this often comes into play is when people are doing artistic things where it's really not going to make a difference on something like this if it's 10-20 thousandths oversized. So we'll go ahead and create our part. And we'll have it add the toolpath by default. And we can see this area here, it's stopping there. And there's some geometries that are so small that it's not even doing. So if we want to go a little bit further into here, we can go to our geometry optimization, click on the toolpath, and we'll change that. Similar fashion, maybe we want to go a little bit further into this one. And some of these you can get some interesting toolpaths if you try to get into some really tight areas. If I set my tool diameter, you can't set it to 0, I can set it to 1/1000th of an inch. And so you can start getting some crazy toolpaths like this. So not sure how that would look when you want to cut it, but hey, again, if it's artwork and it's going to be 20 feet in the air, people might not care. Now, of course, the other option is when you're creating your part, you can just turn off the geometry optimization. So something like this, rather than having to go through and adjust all those per toolpath, I could, when I'm creating the part, turn off the geometry optimization. That turns this kind of hatched color here to let you know that there's some contours that it wasn't able to add toolpath to because they were so small. Well, if we look in on here now, we can see it's similar to what we had before. And you can start to get some, again, some strange results sometimes, but give it a go. If there's something like this that you really want to try to put a lead on or toolpath onto, you can go into your contour. And because collision detection is turned on, that's why I wasn't able to add a toolpath on here. Basically looks at where it's going to put the pierce point. If it sees it's going to pierce into the part, it's not going to let you put the toolpath on there. So if we turn collision detection off, and if we set this internal lead-in type to be a blind lead, which means basically it's going to pierce right on the edge, and click single, then we can at least put a toolpath on there. So as long as collision detection is turned off, you can do some pretty crazy things. Said, ooh, that one. Alrighty. Yeah. So just be cautious when you start doing some of those geometries. Anyways, and then if you do what I just did there, you'd also want to check your cut sequence, because those cuts that I just added are going to happen after the outside cut. So of course we'd want to go to our edit command and reorder those so that they happen sometime before the last cut. So here's the outside cut, and then here are the additional ones that I just added. So then we can just click here and move that down. So there's one other setting that controls or has an effect on the geometry optimization. Let me explode this part again. And we go to create. And at this point here, if I have the geometry optimization turned on, and then I'm looking here and saying, all right, this is 035, let's set this to 0.034, and click OK. So geometry optimization is smaller or equal to tool diameter. So what the heck does that mean? Basically, you can't make it smaller than, if you go into your process submenu, cutting parameters, can't make it smaller than whatever you've got here. If I select again and do 0.041, that's okay. If I do 0.0401, it'll take that. But if I try to set it to 0.40 or smaller, it's going to give me this unless I go into those cutting parameters and change this number. Which again will affect my part tolerance, so be careful about that. And as long as I make it slightly larger than that number I just typed into the cutting parameters, then it'll let me do it. So I hope you enjoyed this deep dive into geometry optimization. If you have any questions, let me know. Thanks.